I'm Christina Fuges with MoldMaking Technology Magazine, and I'm here at AmeriMold with Rich Oles from ROI at the ALBA Enterprises booth. Rich, how does thermal imaging communicate thermal dynamics in a hot runner system?
It's a picture. So it takes complex thermodynamic data that normally people can't visualize and puts it into a context of an image. So even non-technical people that are in an administrative role, that are financially responsible for the plant, can see exactly what's going on. So we explain to people, if it's red, it's too hot. If it's blue, it's too cold. The blue area to turn to red is going to cost you $50,000 if you want it in 24 hours. If you want it in 3 weeks, it's going to cost you $5,000. What do you want to do?
How would it be different for an OEM versus a molder versus a mold builder?
Well, a lot of that has to do with the scale of their operation. So typical OEMs and large tier 1 injection molders, there's virtually thousands of people. So communicating very complex technical information about thermodynamics up to the right person, it's kind of like the telephone game. So when one person tells the next person who tells their supervisor, by the time it gets to the person that needs to make a decision, it's no big deal, we're just down for a little bit. Meanwhile, BMW is going to shut down their production line. So using that graphic image of a thermodynamic issue is a great way to communicate, like we had talked about earlier. And at a mold maker, they can apply that technology in a completely different manner. They can look to see to make sure that the mold is constructed correctly and that a hot runner manifold isn't contacting areas unintentionally. That'll prevent them putting a mold in a press, trying to run it, and it failing.
Can you give an example of how thermal imaging can pick up a problem that other approaches cannot pick up at all or not as quickly?
A lot of the experience I've had since I started my company 3 years ago, I was working with micro and miniature injection molding for medical device manufacturers. They build the molds and they mold the product. And it's such a small mass that it's impacted dramatically by ambient air movement as it comes off, and you can actually warp the parts. So we used the thermal imaging equipment in one case where a device would be set by end-of-arm tooling down onto a conveyor system and be traveling along. And we realized that it was actually affecting the way the part cooled by the conveyor system. Once we took the parts off of the conveyor, we could see this thermal signature on the conveyor belt. And as it ran and ran and ran, the temperature of the belt was coming up and it was impacting the way the parts were coming. So to see that would be impossible.
So what are some future advancements you're seeing with thermal imaging?
Well, the speed of the cameras is changing, the compact size of the camera is changing, and the mobility. They've got add-ons for your cell phone from companies like Seek and FLIR for $500. And they're pretty useful. The biggest issue is teaching people how to use a thermal imaging camera correctly, dealing with emissivity. So one of the future advancements that I hope to be involved with is the ability to negate a plastic part with a thermal imaging camera through filtering and the wavelength of the camera. So it's kind of like X-ray, poor man's X-ray, that you could do live right at the press.
Thanks, Rich. For more information, visit moldmakingtechnology.com.